Okay, guys, welcome to JCon Peru 2022. This time we have Andrew. His topic is modern Java microservices in the cloud. Andrew likes distributed system in all shapes and forms, coding science, the age of A. Wow. He loves simplicity and continuous delivery. Remember, guys, Andrew is Java champion and organize and speaks in different conferences around the world. Yeah. Thank you for participating in this conference, Andrew. And I going to start from I going to together with you, no, from start to finish for the question of the participants. Okay. Thank you,
Awesome.
Andrew,
Sounds
and you
good.
can start whenever you want.
Good. I think that means I can start now, which means welcome to my talk called Simple Modern Java Microservices in the Cloud. And today is we're almost 1,000 days into this thing that makes us do remote presentations. And sadly, we have also this 275th day of Russian invasion in Ukraine. I really hope this finishes quickly. Now, TLDR, if you're sleepy already or not fully awake or, I don't know, in the middle of a lot of things, the short version of this presentation is if you're doing microservices and having a lot of them is hard, then one way of dealing with this complexity is just trying to limit the number of moving things because that will give back in large quantities. Now, a couple details about me. My name is Andrzej Grzesik, but as I realized, this is not the easiest thing to pronounce unless you know how to pronounce it. I also go by Ax. So if you want to reach out to me, you can tweet at me or you can write me an email. The email is very available to anybody who wants to send me a useful message. Don't sign me up for nonsense services, though. A couple facts about me, as it was already mentioned, I'm proud to be a Java champion. I was at Java 1 when you could still become a rock star, organize a conference. I'm involved in JAX, speak at conferences, because I do believe that giving back to the community is very important. And another very important bit is my opinions are my own, which means I am specifically not representing any companies and not sharing any point of views of any companies whatsoever. If you have any questions about my talk, I have one eye on the YouTube on another computer, which means if something breaks and the computer crashes, I have a backup machine almost instantly available. But more seriously, if the question is something I can understand, I'll try to answer. But if I don't notice the question, then it will, through the magic powers of the organizers, arrive at me and I'll try to answer it. Now, I like dry jokes. Feel warned, and if you notice a dry joke, which is in form of a picture, that's also a sign for me to drink some water. Now, talk is called Modern Java Microservices in the Cloud, so it's only fair we start with the word modern. What makes a service modern? Because to make a modern Java microservices, microservice and to run it in the cloud, and cloud is kind of self-explanatory right now because the year is 2022. A microservice is something that everybody naturally understands. If we try to define it, we'll probably have very fueled disagreements and agreements about certain elements, but modern? Oh wow, that's tough. Depending on who you ask, modern might mean different things. And we can have a look at different elements, and we can say that it has to be in a certain language. Somebody might say that a service is only modern if it uses Kafka because everything else is legacy, even if the software like Kafka is actually above 10 years old. Maybe the software has to be in the cloud and that's enough to be modern, or maybe it has to use a specific framework or a specific version of the framework to be called modern. So I don't know, maybe if you use some framework in version 5.7, you are modern, and if you use any other different, you are not. Different opinions are available, and maybe you have to follow a specific architecture. Or maybe, actually, if the software is without bloat, then this is when you have that modern feeling. So what is bloat? I think that's another thing that's people dealing with software naturally understand. But software without bloat As in, this very pleasant feeling when you start to work on a project. You work on a project in which you want to do something, you know what to do, you know how to do it, and almost nothing restricts you. Your productivity is just through the roof. You know the tools, you know the technology, you feel comfortable around it. You know the setup, you know how to build it, you know that you can trust the tests, you know that nobody has had any stupid ideas about builds that, I don't know, use Maven to invoke Ant to invoke something else, and so on and so on. And it all just works, and you can solve the problems because you're also reasonably comfortable around the business area, and you make things happen. And the world is great. And after a day of coding like that, you feel like you have achieved so much done. How do we keep and make software without bloat? Well, that's a bit of a harder question to answer. And I'm not going to try to answer it completely because the details about how do we actually avoid bloat will differ. But we can try to think about what is bloat. Well, yeah, as I promised, dry jokes. And if you recognize the movie, you can grant yourself 10 points. Now, bloat is bloat the language. Maybe if you just use language X, maybe you can avoid the bloat. As in, obviously, if that was true and that would continue to be true, then people using Kotlin would be forever happy. People using Scala would be forever happy. People using maybe C# would be forever happy, and we would never need to change anything language because probably the best language would have already been invented. And I know there will be Lisp fans in the room, and they will say that yeah, it already is. And everybody's welcome to an opinion. On the other hand, we keep getting a lot of development in the language space still, and people are experimenting with new things or less new things, but it's a domain that's definitely not completely stuck and stagnant. And so, yeah, in the context of this talk, modern microservices in the cloud, which language should you do? As in, if you want to do it on the JVM, your choice is somewhat narrowed, but still, which language would you choose? Should you use X or Y? I like to use this kind of check. Imagine that it's late at night. As in, depending on the region, it might not. It should say 5 a.m. and you're just coming back, or you're start to go out somewhere. Let's assume that 2 a.m. Where I live is considered a reasonably advanced night out. And you come back from such an evening, you're not totally done for. You're still operable, and then you have somebody's reaching out to you and, hey, there is a problem in production. Would you actually be in a state that allows you to have a look and try to help us figure out what's breaking? Because I don't know, something important in production isn't. And then the question that I would like to be able to comfortably answer is the language getting in the way? And actually, this is how I choose the languages that I work with a lot or not a lot. Are they going to throw me a lot of surprises? This converges to my personal preference of doing Java and sometimes Scala. Some organizations take it even further because they do only Java. But the bottom line is that the language is very explicit, and what is executed or what is written is executed. There is no magic. And that's just that. There is no magic meta programming. There is no excessive meta programming. I know some organizations who have experienced a lot of meta programming, and even though that gave them tremendous power and productivity in the first weeks of something, then usually everything became very, very stuck. So first bottom line for us is language that does not get in the way, that's explicit, so that there are no hidden surprises, no hidden explosives, no hidden minefields, and so on and so on. Okay, what about frameworks? Well, frameworks, which one should we use? Depending on the date, different versions of different frameworks will be very loudly spoken about. Which ones should we actually choose? Well, there are two rules that I like to apply. Those that have been around for a long time probably will continue being out there for a long time still. And then also sometimes avoiding frameworks might be an interesting choice. As an interesting enough that there are talks at conferences and various events that just suggest using less frameworks. Somebody could say, but why? They give us power and they give us productivity. Yes, but at what cost? Because not only do you have to then learn the business domain and the language and the quirks and ways to do things in a specific technology, but you have to learn how to do something in this technology, in a domain, with a particular framework. And then if it's one or two, it's okay. But if it quickly evolves into maybe 5, maybe 10, and then you have internal frameworks and internal ways of building stuff, and then you actually have quite a lot of technical details that are completely unrelated to your problem domain that you need to learn and reasonably master in order to get anything done. As in, it's like a joke of how complex is it to sort a list, and then how short is it to complex to sort a list in Java using framework X and framework Y built over this thing, and so on and so on. And what about the database? Well, luckily the year is 2022. So 10 years ago, people could have said, hey, you have to use NoSQL because nobody uses SQL anymore. Then NoSQL became not NoSQL, but not only SQL. Now we're kind of back to SQL. So using a relational databases in some places is actually considered okay. Some organizations never moved on. Some organizations went into full Hadoop mode and realized actually there are other things that are complex there. Some organizations prefer not to have an eventual consistency. Now, if you imagine you're building a service that should be reliable, resilient, scalable, but first and foremost, you want to be able to easily reason about the data storage, and you don't have billions of users at your door immediately, then what I found and what I really, really like turns to be Postgres, which somebody could say, hey, but it's a database that's old. And I would say it's not old. It's just been with us for a long time. It's evolving all the time. There are new releases coming out. But primarily, Postgres or any relational database, any classic database, so to say, comes with two benefits. People understand what a relational database looks like and how to work with one. And also they come with very well understood consistency and performance models, which means if you want to answer the question of, is my data storage layer, has it recorded something, maybe a transaction that my customer has done, then in the context of a relational database, this question becomes much easier to reason about compared to some much more complex, much more maybe fancy, maybe modern, maybe exciting, maybe often spoken about at conferences, NoSQL database. I'm not going to mention any names because this is not about bashing any specific technology like Mongo, but yeah, Postgres or stable databases are a way to reduce surprises. So let's keep asking the questions. What makes a service modern? We know it's not the database because we can use something old and still be okay. We know it's not the language. We know it's not the framework. So maybe it's the architecture. Should we all do Lambda? Maybe we should all use Gamma architecture. Should we all do event sourcing? Should we all do something else? By now, you know what I'm aiming at. The answer is elsewhere. Is it the tests? Should you write more of them? Well, obviously, everybody always or almost always wishes they wrote more tests. But I'm going to say this. The bottom line of my rant so far has been like that. Adding new technology complexity to a new business problem is a recipe, and I will let you fill that in any language that you like. Now, this has gotten so far that sometimes you meet people, or at least I have met some, that when you tell them that, hey, I have a problem to solve, before you even tell them what the problem is, and before they understand the problem domain well enough to actually know where software actually can add value, they will say, hey, I want to use Kotlin, Kafka, and Kubernetes. Well, great, let me maybe tell you what we're solving. No, I know that I want to use those code. This is a recipe for something that some people call the 3K apocalypse. And specifically, there is nothing wrong with Kotlin, Kafka, or Kubernetes, together or independently. The problem is with making technical choices and saying that those are the best technologies period, without knowing whether they fit the problem domain. So let's try to come back to our original question. What makes a service modern? And maybe we should actually then ask, is there anything wrong with legacy? And then if you look at this question, is there anything wrong with legacy? Maybe we could actually look even further along this edge and say we might be barking at the wrong tree. Maybe the problem is not in all of us. Maybe the problem is different. Maybe the problem is calcification. Calcification in biology, according to Wikipedia, so I'm not wrong, I'm just quoting, is a process in which calcium salts accumulate in body tissue, which means, for example, skin will become less and less flexible because calcium will have accumulated in it. And that in turn means that everything becomes less and less flexible. It's harder and harder to move. If you know what I'm talking about, you know what I'm talking about. But if you're dealing with software, when there is a system that has a lot of its own ways of doing stuff, if you're joining such a system, this is exactly the feeling I'm talking about. It's only some things are possible because there is a myriad of reasons why some other things are not. And so let's go back in time. And to get back in time, we need a vehicle. Obviously, we're choosing the absolutely best one. If we overdo, we end up in year never, when the Big Bang happened, or maybe not. I don't remember. Not old enough. But according to Wikipedia, year 1997 was when EJBs came around. And Wikipedia also says that this is because of IBM, and then there are people who were working around that space, and they say that this is not entirely accurate. Again, that doesn't matter. I'm quoting Wikipedia, so I take my disclaimer here, but the thing is, 1997 EJBs are at the root of a lot of Java's popularity, because EJBs plus server specification 2.2 means we can do web applications in Java. We can do the magic three-tier web apps, so database, business logic, and presentation layer. Well, however you want to then talk about that. But that concluded, or that resulted very quickly with one thing. In the year 2001 brought us, apart from this awesome movie, and yes, I know this movie wasn't released in 2001, EJB 2.0, which is a major improvement over original EJBs, because EJBs in their original shape and form would do remote, so RMI calls to code running on the same computer, which if you work with RMI, you know that is going to incur a performance penalty, which means it's going to be slow. And also they had this amazing idea of using xDocklet. If you do not know what xDocklet is, keep it that way. If you do know what xDocklet is, if you remember xDocklet, I'm sorry for bringing the bad memories back. But also, what we got immediately after or shortly after was the year 2003. 2003, together with this book, coincided the release of something called Spring in version 0.9. If we were in a room, I would ask who here knows Spring, and I would expect most of the hands or other body parts to be lifted. And time went on. 2005, we get Ajax. As in, you cannot now imagine a modern website not using Ajax. As in, it's like so common thing that everybody just do it. Well, server-side events, do it. Nobody cares about it. It's not new anymore. And obviously, Ajax means, as of now, asynchronous JavaScript and JSON, because it used to stand for XML, but everybody sends JSON right now. And then year 2006, we got EJB 3.0. And EJB 3.0 was a very interesting redesign or approach at EJBs, because it was adopting a much simpler programming model. As in, it was still compatible, but everything became so much simpler. Why? Because original EJBs were considered too complex. And then in year 2014, we got Spring Boot 1.0. Spring Boot 1.0 was a huge revolution that we still are very happy to benefit from, because I know a lot of people who use Spring Boot right now and keep using and will keep using Spring Boot. And Spring Boot happened because Spring was considered too complex. So EJBs, Spring comes up as a reaction to EJBs because simplicity is wanted. Then EJBs come as a reaction to EJBs. to try to simplify, and then Spring does simplification as well. That's curious. That's curious enough that some conference talks generate comments like this. As and I know it's in Polish, but there is my loose translation into English. And this quote says more or less this. Java EE, so Java Enterprise Edition, had a small, well-thought API, 10 times smaller than Spring. Now that we've discussed the history, you know that this is not entirely accurate, but somebody in 2020 thought that this is actually a fair representation of the truth. It doesn't matter whether this person is wrong. It's when you look at the problem from that time and don't deal with archaeology, and I'm not saying that you should deal with archaeology, what comes across is a simpler, well-thought API wins. And is what people want and what people like. 2016, we get microprofile. Some people say because Spring was too complex. What does it tell us? It tells us one very important thing, that we do software in feedback cycles. We produce a bit of software and then we can reason about it. Maybe we can continue the trend and we can realize that, oh my, it's really, really wrong. It's hard, it's inconvenient, and so on. So we like those feedback cycles. We like those feedback cycles when we develop. Because if you use TDD or if you use unit tests, we do a bit of a change. We can have a very short feedback cycle, see if we actually have gotten further along the problem. If we don't know that, maybe we will start with an integration test, or maybe we are going to see if the software actually even connects or displays something, and then we'll get our dopamine shot, and we will have a feedback cycle. Okay, this is how we work. This is when this breaks. Also, we get signal about where in the loop we have failed. If we're using compiled languages, we get a signal from the compiler. Or maybe if we're using a good ID, we're going to get a suggestion or a hint that, hey, what you're doing is completely nonsensical because XYZ, because somebody already has gone through this very problem. And we can save ourselves a bit of time. So we can come back then to our original question of the day, which is what makes a service modern? And while I will not be giving a complete answer to this, I think a very important trend in keeping a service modern or making a service modern and keeping it that way is to keep being simple and to keep and maintain and protect simplicity, because that allows us, the engineers working on the service, to keep the calcification, the complexity, the legacy away. Let's start with Stack. How can we get something like a hello world? Well, everybody does web apps, so how can we do a hello web? In Java, there are many ways to do it. I've picked 3 almost random, as in almost random because I selected them because I know of them, so that's not really random, but 3 approaches. Now, getting a hello world or doing a one-liner in Java is no longer 23 lines, as Java Borat or DevOps Borat used to say, but it is much faster. The very curious of you here will probably notice that this is not exactly Java because this is Scala, but it doesn't matter. It's short. It's a one-liner, or it's in the mental category of a one-liner. The applications are trivial. Spark Java, this has nothing to do with the data analytics. Spark, Helidon SE, or Java. And I picked them because, as I said, I know of them. What can we do with that information? Well, we can create very, very simple applications very quickly with a very minimal API. What you need to come up with a hello world in each of them is just that toolkit, just that library. This is to a point in which they speak of themselves, they speak that they are maybe a web framework, but sometimes also they refer to themselves as REST API or REST libraries or REST toolkits. So avoiding the word framework. Interesting. And then we can have a look, obviously, at the history and activity on GitHub. Helidon started 2018. Okay, so that's 5 years from now. Wow, some history. And then we can look at Spark Java. Spark Java started around 2011. That's over 10 years. So, hey, modern, simple API, over 10 years of history. Let's look at Javelin. Javelin, 2016, around maybe 2017. So there is quite some history behind them, and there are quite some differences in activity. So, It's definitely not about time. So how do we keep services modern? As I suggested before, preventing calcification is the way. How do you do it? How do you prevent calcification? Let's examine how opposite happens. How does complexity happen? My theory is that it happens usually one commit at a time, because I've never met anybody at work who would approach any problem with let's build legacy. Let's just build the most legacy system on the planet that we can. Even in the companies stereotypically not associated with the highest of qualities, people don't say that. I've heard something completely different. I think I've heard people not caring about their job. I've heard people saying, well, let's do whatever, which means they don't care. Or the feedback cycle that I spoke about. So the connection between I write code and what comes in production, what kind of bugs I'm going to get. If they don't have that, and they accept that they don't have that, or there is no way, by the way, organization or the software setup is done, then they are not going to have it. And they accept it because, well, hey, if software pays the bills, software pays the bills. I have my private life after, and I don't care sometimes what happens after 5. Some people approach work like that, and for them, that's okay. So frameworks. How can we choose frameworks so that they don't negatively contribute to complexity? I already told you a story about people choosing technologies before knowing what the project is, and this is not a new trend. This happened long time ago. I first started to notice it when people were hearing of doing a new project and they saying, "Okay, we're going to do Spring and Hibernate," but you don't know what the software is going to be. Actually, it's going to be embedded and not use a database. Your choice is invalid. But one rule of thumb that you can safely use and steal from the stock for absolutely everything technical is the 2 in the morning test. Is this software going to negatively affect how you are able to reason about it? If yes, take your own conclusions. If no, yeah, as well. Why do I say that? Because there are 2 kinds of engineers, not juniors and seniors, I mean here. There are those engineers who have fixed production issues, have been involved in around or close to the operational side of the software, and there are those who just write software and then don't see the effects of that. Why is that difference so stark? Because those who have been closer to the production side, those who were who have had the pleasure of running production updates on a production database late at night, know that having a feedback cycle and being able to reason about what is the consequences of what I am writing is going to very heavily affect what they are doing during the day, every day, since that event happens. Because if you have to deal with the consequences, sometimes unintended, or most often unintended, because we already established that nobody really wants to build the most legacy system out there, then you examine every single decision that you're taking with potential negative aspects. And so we can talk about quality. Well, quality, and the answer to quality is, hey, naturally, write tests. But the question is, when and how much? The way to answer it and approach that as that aspect is, there is another rule of thumb that I can and will have very happily share with you. Know the time you're building for. Not the time you're building for, we need this software ASAP, but know the time you're building for, as in how long is the application that we're working on going to live. Because I can say that it's inefficient to build software that immediately needs a rewrite, which means if I'm writing software that needs to be thrown away after I wrote it, it is wrong. But there is more detail to that aspect. If the application that I'm writing is going, for example, to be a fundament of a financial system, then I probably want to spend the time because it should work correctly, and this application will work for the next couple of years, which means the investment pays off. On the other hand, if you're doing something that only powers a conference stock, because it is used to calculate the dates since Russia started their invasion of Ukraine, for example, and having a lot of tests there is not really that worthy. Because the matter is very sad, but also that software has sees very little very little use. So there is even a chart, and there is even a diagram, and there is even an entry on Martin Fowler's blog. If you've If you know about it, good. If you don't know about it, feel free to take the link and read the whole article. The idea is that there is a connection or relationship between quality and longevity. As you go further in time, quality that you want to maintain will there is a connection between speed of delivery and the quality that you want to maintain. So initially, when we have a greenfield project, we are allowed, or it is possible, to avoid doing anything quality or to limit the investment in quality and actually move faster than if we invested in quality more. Because we're at the very beginning of this chart, we're in a skewed position. But then later, and sadly then, the point is not exactly defined. There is no mathematical formula that allows us to say when do those lines cross. There comes a time when having some tests actually pays off more than we have saved by not writing them in the first place. And this is why knowing what is the lifetime of the software that we're writing, why is it useful? If you're doing a one-time migration tool, if you know that it works correctly and you just run it, and if it worked, you leave it and delete it, the whole repository, probably also throw the computer and the monitor away, then investing heavily in quality makes no sense or makes little sense. On the other hand, if you're doing a system that's going to stay around for just 2 years or maybe just 5 years, and as we know, any quick fixes in technology stay around forever, then having those tests, investing in quality pays off, because over time you are able to reason and to build software faster, quicker, better. We've already talked about it. And how do you do it? If your project is big, how do you measure? How do you approach this area? The technology I use, or the approach that I suggest you also use, is visualization. Have a chart that shows something like coverage, use something like Sonar, use something like a static analyzer, and have the results being visual and being easily available to everybody. Because then what you want is a trend going upwards. You do not want a negative trend. And over time, tiny increments, they will compound. And let's come back to magic frameworks. What do I say by magic frameworks? Or what do I say by having no magic frameworks? A framework that is considered not magic is a framework that has code being run, which is also visible and tested naturally. And if you want magic-free frameworks or a list, you can have a look at Dropwizard, Finagle, Javelin, Helidon, Spark Java. There is more. There is definitely more. I don't claim to be complete. I don't claim to be correct here. The idea is that it's not only that there is those 3 frameworks which are okay and magic-free. No, the notion of going simpler than the biggest enterprise framework out there is old. It's been with us for some time, and some companies have successfully adopted. So maybe some of you in the audience are reacting, saying, "Hey, but we're doing it. We actually are following what you're saying." Yeah, good. That's awesome. But there is a lot of them who don't. So the common attitude here is to say apage to unnecessary complexity. Apage is the Latin word that you use against vampire, and then, as far as some movies claim, the vampire leaves you in peace, obviously, not in pieces. How can you do it? What does an application following that pattern might look like? Well, let's have a look here. We can see 2 chunks of code. One is a public static void main. As you can see, not add application, not extends my app and magic thing. As in, it's a public static void main. We all know what public static void main does if we're doing Java. If we're learning Java, we know that we have to write public static void main, and we cannot do it simpler, but hey. Starting application, getting config, saying .migrate and saying .start. I think if I say to somebody, hey, can you add another database and migrate it as well, you know where to attack this app. If I say, maybe you can put a breakpoint just before the application starts and see what the state the configuration beans are in, it should be trivial. And yes, it should be. And you can see also here that this doesn't use anything strange. It says new, and it injects something in a constructor. So why? Is using constructor-based injection. Is it possible to only use constructor-based injection in application? The answer is yes. Why? Because well, you can get immutability to your class parameters But also, if you have constructor-based injection, you get two benefits. A, you don't need a framework to manage your injection. And if you follow good patterns and allow yourselves to actually be clear, the benefits are not going to be huge. But if you don't, the negative aspects that quickly come into play are longer application start time, because the framework has to scan what's on the app class path, and then it has to figure out, okay, this is actually a bean that's injected here, and this is not injected, and maybe this is injected but preferred, but only up to this point. And then there is logic that has to go into there. Second, if you put @inject, and just add fields into a class, where does it come from? You don't care. So is it possible to inject, I don't know, a database repository into a view renderer class? Yeah, most likely, absolutely, unless somebody configured this framework really well. But in that case, well, there will be other rules. But on the other hand, if we use constructors, and if we have 3 parameters in a constructor, and we're adding a 4th, with a modern IE, this is not a problem. It's one Alt-Enter refactoring in IntelliJ. But if we add 13th field to a 12th field constructor, we can see with our own eyes, hey, maybe this is going a bit too far. Maybe this class is already too big. Maybe it has too many collaborators. And this visual signal is powerful. And it's also available to everybody dealing with the software, not only those who actually want to get a report of how it's all connected. And then another aspect, immutability. Immutability is super powerful with helping your application preserve a state of being easy to reason about. Immutability can be achieved by using case classes. Some languages might call them data or value classes or records. And what can it look like? Well, first of all, it can look like that, so that you have a lot of finals and you do not have any non-finals in your class. And that's good. And then you can see that we have types for everything. As in, there is a wallet owner type, there is a wallet type, there is a wallet ID. So it's not UUID, string UUID, but actually types for specific beings, which means that you know what you're comparing, and you know whether what you're comparing makes sense. If you're comparing a wallet owner ID with a wallet ID, hey, a human is probably not equal a wallet. It's probably nonsensical. I can tell you without looking more into the problem domain. Wallet type being string is definitely different than something else type, which is not a string. But if you compare two strings, hey, they all look the same. And then that ID we already discussed. And then you can see we have a lot of those. And if we have a lot of those, then this guy materializes. What do I mean? I mean, instead of just accepting all the parameters as they are given, do check that they fill whatever criteria you need to be filled whenever you construct an object. It's a very good practice. It's a very low-key, well, not a very revolutionary practice, but actually putting those checks and enforcing invariants in a lot of places can benefit hugely. And I do mean enforce and uphold invariants everywhere. So all of those lines will be created in a software or written in software anytime they are in any time that there are objects created. And then somebody very attentive in the audience, certainly you must be here in the audience. I can hear your thoughts almost. Can say or think, hey, isn't that redundant? Am I not repeating myself by doing this? And the answer to that would be yes, but no. If the system that we're building is, or talking about, or reasoning about, or you're building, is going to live for a very short while, the investment is not going to benefit hugely. But if you are crossing the boundary of multiple months, then those small amounts of stability will produce compound interest, which means they are going to give back, because whenever there is a null that magically materializes, and it shouldn't, it will be much, much, much simpler to see, okay, how could it get there? If you compare it to a stack in which you can have null traverse all the way from the outside, all the way into the belly of your system, and then something exploded, and then you learn about it 2 weeks later, then reasoning about it is going to be much harder. And then obviously, if you're Java 17 or newer, you can convert the class on the left to something on the right. Left one is using a normal class, and or a classic class. I don't want to say a POJO. The right class is using a record, and it's using a constructor, it's verifying, it's doing the same verifications, but records give us equals and hash code for free, which means we're never going to forget about how to write them correctly, hopefully. Somebody could say, hey, but they are not really the same. Well, they are. You can actually do it with a bytecode dump. And then somebody in the audience who knows a lot can say, hey, I can just use Project Lombok. And my answer to this will be, yes, absolutely you can. But it's really a shame I don't get to see you all, because I would love to have asked who here is very familiar with Project Lombok. And then I would ask to all of you in the room, can you tell me how something like this has led to a bug? And I would wait for a few seconds, but because we are remote and I clicked something that I shouldn't have, stand by. Stand by. Window. We are here. We're back. Sorry for that. Somebody thought, hey, add data, that's probably mutable. Let's put it into a hash map as a key. And somebody else added a setter. If you have mutable classes as keys in a hash map, it is actually very difficult to get to the value of that something for a key, because the equals will fail. And that was enough. Obviously, this example was a bit more convoluted when it had to be fixed in production, but it happened. And people who know Lombok can say, hey, but that data is mutable, it's value that's immutable, and person did something wrong and strange. Yes, I absolutely agree. But what I'm saying here is not that it's Lombok's fault, but you cannot see that the problem is what it is without knowing about add data or add value or add setter and so on and so on. Whereas if you see the code as it is, you know what's going to happen, because it's guaranteed that the code you see it gets executed. Let's keep moving. Yeah, nothing wrong with Lombok, but we are against surprises because those make our software unmodern. What about mutability? How can you deal with mutability? Ideally, if you keep mutability in the data store, that's awesome. If you want to use CQRS and event sourcing, consider it, absolutely. And this is where Postgres or any other database that you understand very well keeps coming back, because it's a tool that you can reason about and something that you can be sure about. Also, when your startup or company is very successful and you have to scale, you know what to do, because you can do explain, analyze. You know when the records are stored, and you know when a transaction has achieved visibility, because transactions, again, are known. And Postgres scales. I can tell you from experience. Other people can tell you the same. If you need to do something with databases, also give those two tools a look, because they help managing migrations, and test your data stores with test containers with an actual implementation of the data store you're using. Don't try to pretend that H2 is exactly the same data store that you're using, unless you're running H2 in production, which I don't think you are. And then another framework or a library that is very much in the spirit of let's keep it simple and let's keep it being very explicit. One I wanted to mention now is called Juke. Juke is a DSL for dealing with relational databases. You write a query like that using methods. What is the benefit? It's going to produce correctly SQL. What is the added benefit? It is producing SQL, which means who here has, I know, no show of hands, but who here has tried to get all of the SQLs out of Hibernate or JPA or anything else like that? First of all, do you know how to do it out of the box? Can you easily fish out the correct query that you're interested in because something is off in the database? Have you ever been bitten, even a tiny bit, by Hibernate's performance? And I'm not saying that there is anything wrong with Hibernate's performance, but because it has 2 layers of caches, there are surprises. If anybody is saying yes, well, look at them. But because we're using YouTube, well, think that somebody there must be. The other benefit of using Juke or something that's very explicit in the SQL that is sending against the database is you get a very easy access to those SQLs, which means if you need to do an explain analyze, which is going to tell you which exactly indexes are being used, you can do it easily. If you need to change it, you do change it. Yes, it takes a bit of development time, but in a system that's going to live for a long while, it's usually worth it. And then we are sadly running slowly out of time, which means I can mention that legacy will eventually happen because it is very hard to keep it away, and there are bits of systems that are going to just stay untouched and unmaintained, maybe unloved, and there is nothing wrong with that. It's perfectly fine. And one notion that I will finish with is because software is read more often than written, then people change across companies. And what really matters to people is knowing what they are responsible for and the architecture and having this mental model and being able to see what the software is like, what the software should look like, how it works. I don't mean documenting microservices like that, because this makes cool Twitter pictures, but it's actually not that great apart from Twitter. So how to document? Do something called architecture decision records. If you know what it is, awesome. If not, there is a link to GitHub. Have a read at it and start capturing the biggest changes around your system, the biggest decisions around your system, because the future you or your future colleagues are going to bless you that you have described the consequences and the context under which you were making decisions. Who should make those? Easy. Every engineer. Who prepares documents, who reviews them? Engineers. Why? Because engineers operating with the system have skin in the game, which means they have the feedback loop because they have to deal with the consequences of actions done. And then we're engineers. We want tools. What should you use to diagram? You don't need enterprise architect. You don't need expensive fancy software. You can use something text-based like Plant UML. And what model should you use to make those diagrams? I would say explore the C4 model. It's a well-working starting point for I need to get the some documentation about our system, and I don't know how to do it. Should I learn UML? Should I send myself to a UML certification course? Maybe. Absolutely not. You explore the C4 model, use it, and apply the useful elements out of it. And the moment you have to do something else, well, there are talks about it and explore them. Text is king because you can add this text into your source control, and that means we can probably see if we have any questions, and I should also recommend some books because I always promise to do that. So book recommendations, here they are, and in the meantime I will see if there are any questions that the organizers want to relay to me. So far, there is nothing. In that case, I'm going to say this. Enjoy the conference. It was an absolute pleasure to present to you, albeit virtually. I really wish we get to meet in person and we get to upgrade this to a handshakeable, after-event drinkable kind of event. TLDR is there is enough complexity in the business, enough as in a lot. If you're optimizing for the long term, optimize for the long term. Investing in quality will pay back. Build the quality and build resilience at many stages, because that's going to give back to you a lot and at many occasions. Software that is simple to understand, simple to scale, and simple to change is usually easier and more pleasant to work with, and you will probably end up calling it modern. And I'm going to say thank you very much for being here with me and for waking up. May the force be with you. Bye-bye.
Okay. Thank you, Andrew, for sharing all this information. Personally, I will review your session several times to take notes of all the details you have shared that is a result of your experience. Congratulations. For the time for the next session. For this reason, I will stop the streaming in 2 minutes. Thank
it
you.
Was a pleasure. And hopefully we get to upgrade this to an in-person experience. Good luck with the conference. Enjoy.
Okay, Andrew. Thank
Take care. Bye-bye.
you for sharing your experience with the Peru community and participants in general. We hope to have you in face-to-face edition in the next year.
Sounds
and
good.
You get to know Lima, Peru.
Take care. Bye-bye.
Okay, bye-bye. Okay, guys, remember the IntelliLicenses licenses that we will raffle is only for those who participate by asking the speaker questions, okay? In Spanish, chicos, ustedes se van a ganar estas licencias solo si participan haciendo preguntas para el speaker, ¿ok? También en el caso, por ejemplo, de Andrew, que ya terminó su sesión, lo pueden hacer por Twitter, ¿ya? La cuenta es PeruYuk, ¿ok? La cuenta es PeruYuk, lo puse ahí en el chat, así que todo es válido, pero mientras esté en el rango de la conferencia. O sea, si más adelante ¿no? ves el video y dices, uy, esta pregunta se la voy a hacer a Andrew, ¿ok? Entonces, háganla. Nosotros lo vamos a tomar y al final, en el cierre, vamos a sortear las licencias, ¿ya? Eso es lo que nos piden los de Intellit, ¿no? Tiene que haber una participación del speaker, ¿ok? Así que nada, chicos. Remember that the Intellit license that we will raffle is only for those who participate by asking the speaker questions, ¿ok? Solo para aquellos que hacen las preguntas. Nos vemos en la siguiente sesión.